In section 1.4, number 23, I need to verify this equation by using factoring, and fundamental identities. So factoring and fundamental identities is kind of our hint of how to start. So I'm going to recopy the left-hand side and try to manipulate it to get to what's on the right-hand side. So try to get it to equal tan. So I'm going to start with sine of theta, cosine of theta, plus sine of theta over cosine of theta plus cosine squared of theta. Now to factor this, I look at just the numerator and denominator one at a time, and I can see there's a GCF in each of these. So first thing I'm going to do is GCF. And I can see in the numerator, I have a sine theta in both terms. So I'm going to take that out. And what I'm left with, after I divide both of those pieces by sine, I'm left with cosine theta plus 1. In the denominator, I have a common term of cosine theta in both. So I'll factor that piece out. And what I'm left with, after I divide cosine theta from each piece, is 1 plus cosine theta. Now, addition is commutative, so I can change the order. That's what that means. Let me just move this down a little, get myself some more space. Okay, so that means this thing is equal to this thing. In a fraction, you have to be careful about canceling things that are equal, denominator and numerator. If they're, for example, if I have sine over here, I couldn't cancel two things are equal because there's a plus sign there. But if there's no plus signs and it's just multiplication, then division will cancel it. So cosine plus 1 and 1 plus cosine are the same thing. They're factors. There's no addition and subtraction in this fraction anymore. So I can just cancel those pieces out, and I'm left with 1 and 1, which leaves me with sine of theta over cosine of theta, which I know by the fundamental identities is equal to tangent, which is what I wanted to equal, which means my identity is now proven.